somewhere out there in the dark, there is a line you cannot see. It has no wall, no marker, no warning sign. But the instant you cross it, the universe makes you a promise it never breaks. You are never coming back. Not your ship, not your body, not even the light bouncing off your face. Today, you and I are going to cross that line on purpose. Because that line wraps around a black hole, and a black hole is simply what happens when gravity stops playing fair and wins completely. Crush enough mass into a small enough space, and the pull gets so violent that the speed you would need to escape climbs past the fastest thing that exists, light itself. And once light cannot get out, nothing can. But that is the easy part. The hard questions are the ones that keep physicists awake at night. What would actually happen to your body on the way down? And what is waiting for you at the very bottom? To answer that, you first have to understand what a black hole really is, because almost everything you have been told about them is wrong. A black hole is born when a giant star runs out of fuel and dies. Without the outward push of its own burning, the core caves in under its own weight, crushing a mass many times heavier than our sun into a region almost unimaginably small. What is left behind is an object so dense that gravity near it becomes monstrous. But here is the myth we have to kill right now. A black hole is not a cosmic vacuum cleaner roaming the galaxy, sucking everything in. If you swapped our sun for a black hole of the exact same mass, the Earth would not get pulled in at all. We would go dark and freeze, but our orbit would not change one bit. Gravity only turns terrifying when you get close. And there is a real, measurable size to every black hole, a boundary called the event horizon. A black hole a few times heavier than the sun has a horizon only about the size of a small city, a couple dozen kilometers across. But the monster at the center of our own galaxy, called Sagittarius A, is over 4 million times the mass of the sun, with a horizon so wide you could line up more than a dozen suns across it. So now you are falling toward the event horizon, that boundary, the line we keep talking about. And the very first thing it does to you is bend time. Not in a poetic way, in a measurable, clock-ticking, this actually happens way. The event horizon is just the exact distance where the escape speed finally equals the speed of light. It is not a wall. There is nothing there to touch, no shimmer, no surface, just an invisible boundary drawn in empty space. You could drift across it and never feel a thing. But to anyone watching from a safe distance, something impossible happens. As you approach the edge, they see your clock tick slower and slower. Your image stretches, turns red, and dims. And right at the horizon, you appear to freeze, hanging there forever like a photograph that never quite finishes developing. From the outside, you never actually cross. And yet from your seat, nothing feels strange at all. Your watch ticks normally. You sail straight toward the line. So you have to wonder, when you finally cross it, will it even hurt? Here is where gravity collects its bill. Because the pull near a black hole is so steep, the force on your feet is far stronger than the force on your head. Your body gets stretched, head one way, feet the other, thinner and thinner, until you are pulled into a long human strand. Scientists have a real name for this. They call it spaghettification. But whether that kills you depends entirely on which black hole you chose. Near a small one, only a few times the sun's mass, the stretching becomes deadly long before you ever reach the horizon. You are torn apart in the approach. But a supermassive black hole is so enormous that the pull is gentle and even across your body at the edge. You would cross the line whole, conscious, and completely alive. So the honest answer to what happens to your body is, it depends. Pick the small one, and you are spaghetti before the show even starts. Pick the giant, and you get a front row seat to the strangest journey a human could ever take. Let us assume you were smart. You picked the giant, and you survived the crossing. You are now inside the event horizon, past the point of no return, and somehow still alive. So look up, because what you would see from in here is a view no telescope will ever capture, and no human has ever reported back. All that crushing gravity bends the path of light itself, So the entire outside universe gets squeezed into a single brilliant circle above your head. Every star you ever knew compressed into a shrinking, glowing porthole, while pure blackness closes in from every other direction. And here's the part that breaks people. Inside the horizon, the center is no longer a place you could choose to avoid. It becomes a moment in your future, as unavoidable as tomorrow. Every direction you could possibly move, every path you could steer, all of them now lead to the same single point. Falling is no longer a choice, it is your destiny. But if light itself can never climb back out of here, that raises a haunting question. Does that mean a black hole simply lasts forever? Everything you are is now racing toward that one point, the singularity. And our best equations say that here, all that mass is crushed into a place with zero size and endless density. The math does not give us a number. It gives us infinity. And in physics, infinity is not an answer. It is a flashing red light that says your theory just broke. Because the truth is, nobody actually knows what is down there. The rulebook of gravity and the rulebook of the quantum world, the physics of the very small, flatly disagree at the center, and we have no proven theory that combines them. So when we say singularity, what we really mean is this is where our understanding ends. So the center of a black hole is not really an answer at all. It is the single biggest unsolved mystery in all of physics, locked behind a one-way door that no signal, no probe, and no person can ever come back through. That is the brutal honesty of it. We built the door. We just cannot see what is on the other side. But here is the twist almost no one sees coming. Black holes are not eternal. Thanks to a strange quantum effect right at the edge of the horizon, a black hole very slowly leaks tiny amounts of energy into space. This is called Hawking radiation, and bit by bit, over time, it makes the black hole shrink. Now, this is breathtakingly slow. A black hole will outlive every star in the sky, glowing on long after the last sun burns out. But eventually, after a number so vast it barely means anything, it evaporates and vanishes in a final flash, which leaves one terrifying question. Everything that ever fell in, every person, every star, where did all of that information actually go? So that is the journey. An invisible line you can never cross back over. A body stretched into a strand, a frozen image of you hanging on the edge for all eternity, and a silent giant that is very slowly already dying. A black hole is beauty and terror folded into the same object. We started at a line you can never uncross, and we ended at the very edge of human knowledge.